So in the previous lesson, we talked about the properties of a triangle. In this lesson, we are going to talk about the properties of a quadrilateral. So once again, there are a lot of properties about quadrilaterals, but we're going to focus on 3 of those properties. Okay, so the first one is something, once again, you've seen in grade 9 now. I don't know if you remember it, but you know what? We're going to start with quadrilateral A, B, C, D. Okay, we're going to have the midpoints of A. Okay, we're going to have the midpoint of BC, the midpoint of CD, and we're going to have the midpoint of AD. And what we are going to do is join the midpoints of the adjacent sides. And if you join the midpoints of the adjacent sides, you are actually always going to get a parallelogram. The quadrilateral that you form by joining the midpoints of the adjacent sides is always going to be a parallelogram. So that's a very interesting property of a quadrilateral. So let's write that down. Quadrilateral formed by joining midpoints of adjacent sides is a parallelogram. So it doesn't matter what quadrilateral you start off with. Once you join the midpoints, you'll get a parallelogram. All right, what about this one? We have a parallelogram here. Okay, so let's A, B, C, D. Let's start with that. So we have a parallelogram here. And you know what we're going to do? We're actually going to draw the diagonals of the parallelogram. So I have 2 diagonals. Okay, if you join AC, you have one of them, and if you join B and D, you have another diagonal. So, interestingly enough, the diagonals of a parallelogram always bisect one another. Okay? The diagonals of a parallelogram always bisect one another. So, let's see. Diagonals of a parallelogram bisect one another. We actually proved this in grade 12 in the vectors portion of calculus and vectors. But you can actually prove this using just grade 10 knowledge in the 7th chapter again. If you can prove that, well, you can prove that, let's say this is E. This is where the midpoints intersect. So, sorry, where the diagonals intersect, which bisect the 2 midpoints. They bisect the 2 diagonals. Anyways, I can prove that triangle AED is congruent to triangle CEB. And if I can prove that they are congruent, then it makes sense that EB and DE are equal in length. And then conversely, I can also prove that triangle ABE is congruent to triangle CDE. And then that will prove that this length AE is equal in length to EC. So yeah, I can use congruent triangles to prove that diagonals of a parallelogram bisect one another. But you know what? That's for another day. You can come back to this at the end of the course and prove this to yourself. Okay, so this last property of quadrilateral focuses on a trapezoid. Okay, so let's see. So I have a trapezoid, which means one pair of sides are parallel to one another. Okay, and what we are going to do is we are going to do something very similar to what we did with triangles, which is find the midpoint of two sides. So let's say this is E and let's say this is F. So E is the midpoint of AD and F is the midpoint of BC. So what I'm going to do is draw a line segment which connects the midpoints. Okay. Alright, so this line segment is very, like I said, it's very similar to the mid segment of a triangle. In fact, some textbooks call this the mid segment of a trapezoid. Some people call this the median of a trapezoid, or some textbooks, and some textbooks call this the midline of a trapezoid. Okay, so there's a lot of different names we give it, but let's go with, I believe the textbook goes with midline. Anyways, they're all meaning the same thing. So we're gonna say line segment EF is the midline. You know, I'm gonna give you the three words. So median, midline, mid segment. I'm pretty sure our textbook uses the word midline. Anyways, of the trapezoid, so is parallel. So I didn't tell you, it's actually EF, the midline or mid segment or median, is parallel to the other two sides. And when I say other two sides, I mean the parallel sides of the trapezoid, because these are the two sides you work with to create the mid segment, and then these are the two remaining sides when I say other. And not only that, average the length of the parallel sides. Okay, so I can find the length of this mid segment or the midline by finding the length of AB and length of DC and then averaging the two, and then that will give me the length of EF. So it's a very interesting property. So we have three properties, and we're going to do exactly what we did last time, which is basically work on some questions which requires to verify these properties. Okay, so classify the following quadrilateral. Oof. Okay. So let's plot the points. 1, 6. Okay, 6, 6. 4, 3. And negative 1, 3. Negative 1, 3. Okay. So just by drawing that, I see a parallelogram, but you know what? We should really do the math. So remember our shortcut, which is do 4 slope calculations and 2 length calculations. Okay. So slope of AB, let's see, 6, 0 over 5, which is 0. Slope of BC is equal to negative 3 over negative 3 over negative 2, which is 3 over 2. Slope of CD is, I know it's 0, but it's 0 over 5, which is 0. And you'll know, like last time, why we don't simplify right away. The AD would be negative 3, negative 1 minus 1 is negative 2, which is 3 over 2. Good. So I verified I have a parallelogram. It's not a rectangle. It's not a square because adjacent sides are not perpendicular. So is it a rhombus? So length of AB and the length of BC. Oh. Nine, 4, 13. Oh, that's boring. It's just a plain old parallelogram. He's not a special parallelogram. So since slope of AB equals slope of CD and slope of BC is equal to slope of AD, you can also add that slope of AB is, slope of AB times slope of BC is not equal to -1, and you can say length of AB is not equal to length of BC. Therefore, what can we conclude? Quadrilateral ABCD is a parallelogram. Boring parallelogram. Yeah, nothing special about this one. That's a little unfortunate. Okay, another one, classify the quadrilateral. Okay, do I want to plot this one again? Let's do it. -2, 6. PQ is -10, 4. R is -12, -4. S is -4, -2. Okay. Okay, we got PQRS. So let's find slope of PQ. -2, and then 10, -10 minus -2 is -8. So that's 1/4. Slope of, let's see, what do we have? QR. QR, so it's -4 minus 4 is -8. -12 minus -2, which, one second, -12, yeah, that's -2, so this is 4. Slope of RS, so it's -2, is 2, -4, that's 12, that's 8, that's 1/4, beautiful. Slope of PS. Okay, -2 minus 6 is -8, and then -4 minus -2 is -2, so that's 4. Okay, good. So right now I can tell you it's square, or wait a second, it's just a plain old parallelogram. Maybe it's a, oh, it's a rhombus. I can see because the length of PQ is 4 plus 64 is 68, and length of QR. So it's definitely not a square rectangle because the slopes are not negative reciprocals. Be careful, the reciprocals, adjacent sides have reciprocal slopes but not negative reciprocal. Big difference. Okay, so adjacent, so opposite sides are parallel, and they're not negative reciprocals, adjacent sides. So adjacent sides are not perpendicular, and all 4 lengths are the same. So guess what? This quadrilateral is a rhombus. Good practice on classifying. Okay. Alright, verify diagonals bisect each other. Okay, we can do that. So midpoint of PQ Let's see. Midpoint of PQ is negative. Oops, not PQ. The diagonal PR. PR. So it's negative 2 plus negative 12 over 2, and then 6 plus negative 4 over 2. So that's going to be negative 14, negative 7, 2, 1. Okay. What about the midpoint of the other diagonal? QS. QS. So it's negative 10 plus negative 4. 4 plus negative 2. Hey, what do you know? Alright. So since the midpoint of PR and midpoint of QS have the same coordinates, therefore diagonals bisect each other. Now, because this is a rhombus, not only do the diagonals bisect each other, but the diagonals are perpendicular to each other. So all you have to do is find the slope of the diagonals and show that they're negative reciprocals. So let's see, the slope of PR is, let's see, PR. So it's, let's do 6 minus negative 4 and negative 2 minus negative 12. Okay, so this is 10, and this is going to be 10, which is 1. Okay, what's the slope of QS? QS, so it's looking at negative 2 minus 4, and then negative 4 minus negative 10. So that's negative 6 over 6, which is negative 1. Yes! So since the slope of PR times the slope of QS is negative 1, therefore diagonals are perpendicular. We can say diagonals of quadrilateral PQRS. Okay, so we have 3 properties for quadrilaterals, and we can verify some properties given some information. As long as you know your slope calculations and your midpoints, you need to know what you need to find. Like, to prove that diagonals bisect each other, you need to find the midpoints of the diagonals and show that they have the same coordinates. Okay, but yeah, as long as you know how to do the calculations for slope and the length, you should be able to piece together and verify the properties.